Good afternoon, everyone. My name is Saikishore. The title of my paper is Pairwise Preferences-Based Matrix Factorization and Nearest Neighbor Recommendation Technique. In the introduction, most of you would have seen many recommender systems which are rating-based, meaning that users make absolute evaluation on items. In particular, for a classical 5-star, you see users making absolute judgments on items, either saying it's 5 stars or 2 stars or 3 stars. But if most of the items are 5 stars, how can we differentiate among them? In particular, consider a user who wants to rate 2 items A and B. He rates item A as 5 star, and later he finds item B better than item A and wants to give higher rating, and eventually gives 5 star both items. So considering some of these limitations, a few authors in the literature, they used pairwise preferences. What exactly is a pairwise preference? Given a pair of items, a user can say which item he prefers and to what extent by a score. You can see here a particular user is trying to say that he likes Clockwork Orange 2 times better than Independence Day, and another user might say other way around. So in this work, we use such kind of pairwise preferences to build recommender systems. Let's see some of the state of the art, and before that, most of the research in recommender systems is dominated by rating models, and very few have used pairwise preferences. And we found these as the top algorithms. And the first one is a prediction algorithm, which uses Pearson correlation as a user-to-user similarity to predict the unknown pairwise preference. And the second one is a matrix factorization, which uses inverse logit function to predict a missing pairwise. And the final one is a popular Bayesian personalized ranking, which has applied to pairwise data applied for implicit data. And our contribution here is that we propose our contribution is 2 ways. The first one is propose a matrix factorization. In matrix factorization, what we do is we replace items with pair of items. And in nearest neighborhood, we feel that Pearson correlation is not appropriate for pairwise preferences. And what we do is we propose 2 new similarities that can be used when you have pairwise preferences. And in our first contribution, we have a matrix factorization for pairwise preferences. If you can imagine the matrix factorization for classical ratings, what we do is that we replace, instead of items, we have pair of items. So that's the reason instead of Qi, we have Qij, where we have a factor vector representing each pair, and similarly for the bias. And we predict a missing pairwise preference like that. And we use stochastic gradient to learn the model parameters. And in the second contribution, which we propose 2 user-user similarities. And the first one is GK, taken from the literature. GK is calculated based on 2 quantities, the number of pairs which are in the same order, and the number of pairs which are in the reverse order. So you just observe the user profile and just calculate how many agreements and disagreements happen, and you put in this formula, you find the similarity. And once you have the similarity, you have a neighbor pairwise preference, and if you predict pairwise preference for the user. And here, let's quickly see an example here. You see, when you observe the table here, we have 2 users and a pair of items here, and the user's pairwise preferences. Observing the table, you can find that both users are not similar. One prefers K here, other prefers J, and one prefers K here, other prefers L. But when we use Pearson similarity from the literature, we get a relative high similarity. And at the same time, when we use our proposed similarity, we get a -1, which is apt in this case. In our second contribution and the second similarity matrix, it's expected discount rank correlation, which is asymmetric in nature, and it was earlier proposed to evaluate a ranked list obtained from implicit data. So what we have done is modified a bit and use it as a user-user similarity. So again, taking the same example, EDRC is basically based on a graph representation. So you have this user profile, and you start constructing a user graph. So you have user, and where you construct a graph where items represent the vertices and the pairwise preference represents the edge. And what EDRC does is that it will try to see how much a user graph match with other users. And to do so, it requires a set of scores, which are rank score, a discount weight, and the score CB. I'll explain in the next slide how you calculate. But before that, again, using EDRC, we get a negative similarity, which is apt in this case again. So in order to calculate the rank score, what we do is that we take the user graph, initialize each vertex with 1, and you just update by traversing to the graph. And you make a linear discount assignment. And finally, the score CV is nothing but it checks how the both users agree overall on a pair of items. We have a set of agreement rules. If a users agree both on the pair, we take it as 1, and if they don't agree, we take it as 0, and if we do not know, we take it as 0.5. Once we calculate these values, we put it in this formula to find the similarity. Enough. So far, I've said how to predict a missing pairwise preferences, but we need a ranking to present the users. So what we do is that we just average all the available pair scores. So imagine that for a user, we construct a matrix item and item, and we fill the corresponding pairwise preference here. And for each item, what we do is we just average this one and give a score, and we rank according to that particular score. And in the evaluation, we have a movie data set where users were explicitly shown a movie page, and they compare those two movies. And we used a 5-fold cross-validation, and we have averaged our results. In our metrics, we use these metrics. The first one is a prediction metric. What it does is that we have a recommender which will predict a missing pairwise preference, and in the ground truth, it tries to check whether the order is correctly predicted or not. In some sense, it tries to count number of hits it happens here. And the rank hit, it's nothing but it will evaluate the ranked list. Here, for example, if a user says that he prefers A to B, and in the ranked list, we check whether A appears before B or not. And the last one is just an extension which will calculate the cutoff of, let's say, top 5 or top 10. And finally, our results, as you can see, the higher values are always better. And below the line is a baseline, above one is our proposed ones. As you can see, the EDRC is the top algorithm, and which says that when you have pairwise preferences, a tailored similarity can be used. And our contribution matrix factorization, again, able to give better results. And in addition, it is able to take into account values from -4 to 4. And finally, the BPR one, our models, what it does, given a pair, it tries to predict which item he prefers. But whereas BPR will try to predict a ranking based on the observed scores. And in our conclusion, we proposed 2 approaches, and there are some critical issues here. The first one is how to effectively form the pair so that we can have this pairwise preference elicitation so that the pairs are comparable, some of the active learning strategies. And we are trying to understand when and where the pairwise preference elicitation could be beneficial. Is there a place where you can use pairwise preferences and effectively learn user preferences? And thanks for your patient listening. Any questions?
In your comparison of the different methods, how did you optimize for the hyperparameters in the benchmark?
Sorry, say it again.
How did you optimize the hyperparameters in the BPR?
I've used this 5-fold. We have 5-fold one. I've calculated on the first fold, and I kept it constant for the other folds.
In the search literature, they have something called learning to rank, and they'll take the results shown on the page, and if the user clicks on the 5th one, they think that you.
I'm sorry. Could you speak slowly?
Sorry. In the search literature, they have something called learning to rank, and they build models using pairwise preferences, where if the user clicks on the 5th item, they say you preferred 5 to 1 through 4, and you generate pairs that way, sort of implicitly. Are you familiar with that and how that would compare to this?
No, we have not considered any implicit kind of thing. So we have a pair of items, and a user says that to what extent they like which movie, that's all. Mm-hmm. We do not consider, but maybe in the future we'll like to consider such things.
Yeah.
Thank you.